Hi everybody, welcome to lesson 9 in which we're going to convert between standard form and vertex form when working with parabolas. So in the last lesson we played around with vertex form and saw it was really powerful in giving us the zeros and the vertex and the graphs of our quadratic functions. So today is actually going to be a really big day of completing the square. That skill we learned back in unit 8 to solve quadratic equations is actually going to help us working in vertex form. So consider the following quadratic functions. Remember, these are x squared functions. These are all parabolas. Describe what we know about the graph of each function just by looking at the equation. So this first function here is written in standard form. Why is it written in standard form? Well, the exponents are decreasing. I go from the highest power to the lowest power. I have 2x squared minus 8x minus 24. It's a trinomial. That's standard form. It doesn't give us a lot. It gives us the leading coefficient, fine, but what it does give us is the y-intercept. The y-intercept is negative 24, is all it really gives us. It gives us that y-intercept point on the graph, but with parabolas, the y-intercept isn't that important. The y-intercept isn't important when we work with standard form. But what is important are the other two forms that we learned, which is factored form. Someone did factoring here. Someone factored this parabola. So this is factored form. Notice it's written as a product. It's written as its factors. So what this tells me is this tells me the zeros. The zeros of this function are 6 and negative 2. I can quickly tell you that because I just applied the zero product property really fast. What makes this factor 0? 6. What makes this factor 0? Negative 2. So standard form's great, but we can factor it to get into factored form. Again, we know the leading coefficient is 2. And again, this last form gives us the leading coefficient of 2, but what it gives us is it gives us the transformations. It gives us the vertex. Hopefully you notice that this was vertex form. It's written as something squared, and I can tell you the transformations. The transformations are right 2 and down 32. So instead of starting at 0, 0, this has a vertex. It's called vertex form because it tells us the vertex. Vertex is right 2, down 32. So I'm going right 2 and down 32. That's the powerful thing of vertex form compared to standard form. So we know how to get to factored form, you factor, but to get to vertex form, we need to do a little completing the square. And yes, that is the Cornwall fire whistle blowing in the background of this video, in case you're wondering what that siren is, if you can hear it. If not, well, then you know that there's a fire call right now, or there's a fire call at 8:40 when I'm recording this video. Hopefully there's not one right now. So today's game is going to be, how do I start in standard form and end up over here in vertex form? How do I make something into a square? Well, that's our good friend complete the square. So hopefully you're ready to draw some boxes. Hopefully you're ready, you remember that process, but if you don't, we're going to go over it right now. So rewrite this function in vertex form. Well, there's a problem. That leading coefficient is a problem. So what we do is we factor it out from the first two guys. X squared minus 4x. And that, remember when we complete the square, I only care about these guys right here. I don't care about the constant term. Well, then we draw our box. We draw a box. So we've got x squared, x times x. What do we do with the middleman? Well, we cut him in half. We cut him in half. So the magic number is negative 2 times negative 2 is 4. 4 is the magic number that completes the square. So let's stick that in. Let's stick that into this expression here. 2x squared minus 4x, magic number of 4. Here's where we have to be careful. We have to counteract that. I wrote plus 4, but there's really a 4 times 2, which is 8. So how do I counteract an 8? How do I counteract an 8? I need to do a minus 8 on the outside. I need to do a minus 8 on the outside because I wrote 4. 4 times 2 is 8. So I need to do a minus 8 on the outside, and the negative 24 was there. One more step and we're done. How does this factor? That factors as x minus 2 There it is on the side of my box there. X minus 2 squared. Combine my terms over here, and I get negative 32. This is in vertex form, so f of x. This was standard form. I use the process of completing the square to get it into vertex form. That's the whole idea of this lesson. How do I get from standard form to vertex form? I complete the square. I complete the square to make that jump. Using this information, we can graph it. Let's skip that part for the sake of time, because we've got a lot of completing the square to do in this lesson. So I'm not going to do the whole lesson. I'm going to focus on the basics, the major stuff we need to know here. So rewrite these in vertex form. Tell me the vertex, is it a max or a min? So let's take some time to go through this. Let's take some time so that we get good at this, and that way you understand this process. So I like it because it's 1x squared, we're good to go. I'm going to complete the square. I'm going to draw my box. Cut the middleman in half. Remember, I'm not factoring right now, I'm completing the square. X times x plus 3 plus 3. 3 times 3 is 9. So that's the magic number I need to add. I need to add in plus 9. But I can't just add in 9 into an expression. That changes the value. I need to change its appearance without actually changing its value. I need something that's equivalent. So how do I counteract adding 9? Well, I subtract 9. This one's easy because there's no number out front, so I'm good. Positive 9 and negative 9, those undo each other. But I can't forget about that negative 2 that's been there. And now we're done. Y equals... How does this factor? We'll look at the square we made. We made x plus 3 squared minus 11. That's my equation in vertex form. Before, you couldn't tell me what the vertex is. Now I can tell you the vertex is left 3, down 11. So my vertex is negative 3, left 3, down 11. There's my vertex. Well, is it concave up or is it concave down? That depends on a positive or negative leading coefficient here. Since it's positive, I'm concave up, which means this is a minimum. It is not concave down, it is concave up because the leading coefficient is positive. You can tell me that from the start. The leading coefficient is what's in front of x squared. 1, I'm concave up, therefore I have a minimum as a vertex. Okay, so remember, to get to vertex form, we complete the square. All right, let's do a little bit trickier one. Let's do a little bit trickier question here. This 5 is a problem, so what do? Is we factor it out. We factor that 5 out, divide by 5, divide by 5, and we leave that 23 alone. So draw me a box so we can complete the square with this. X squared, cut the middleman in half. I love completing the square. I hope you do too. 2 times 2, the magic number here is 4. So I want to stick in to that set of parentheses there a 4, because 2 times 2 is 4. But I need to counteract that. How do I counteract adding in a 4? But wait, it's not really a 4, it's really a 4 times 5 is 20. So I really added in a 20. How do I counteract that? I need to subtract 20. I added 20, even though it looks like a 4, that's really adding 20. So I need to subtract 20. And that 23 is there for the ride. So my final answer is 5, x plus 2 squared, x plus 2 squared. Combine like terms, I have a plus 3. So my vertex, well, what transformations occurred here? Think back to those transformation lessons. I need to go left 2, up 3. My vertex is left 2, up 3. And I'm concave up, so this is a minimum. That vertex, that turning point, is a minimum. All right, 2 more, and then we'll call it a lesson at that point. 2 more, and then we'll call it a lesson. All right, there's a negative 1 here. So first of all, that leading coefficient, I can already answer this. I'm concave down, so my vertex is a maximum. I can tell you that right from the start. I know my leading coefficient's -1, but I've got to factor that out. So I need to divide by -1. This is already negative, so it's going to become positive when I factor it out. You got to be careful with that -1 there. It gets in the way of me drawing my box. X squared is x times x. Cut my middle man in half. Slice it in half right there. Chopped it in half to get 6 and 6. Well, 6 times 6 is 36. Pretty sure I learned that in 2nd grade. So -1, x squared plus 12x, magic number of 36. Now it's time to counteract it. Well, let's think for a second. I added 36, but I wrote 36, but is that really a 36? No, it's really a -1 times 36. So this is a -36, so I need to counteract that with a positive 36. Those don't look like they cancel each other out, but they do, because this isn't really a positive 36, it's really negative. So our final step is to write the answer. -1 times what squared? What's squared here? X plus 6 squared plus 3. I combine my like terms out there. So my vertex is go left 6, go up 3. Left 6, up 3. So -6, 3. And like I said before, that's a maximum. That's the highest point of this parabola because my leading coefficient is negative. My leading coefficient is negative. Let's do one more just to make sure we've got this under our belt, and then I'll let you try some on your own, and can't wait to see what great work you send me. So we got a problem. We've got that leading coefficient to work with, so let's take care of that. Let's take care of this leading coefficient here by taking it out. Let's factor it out. So I factored out a -2, so that means I need to divide this by -2. 4 divided by -2 is -2x. Let me make a box and cut my middle man in half. X minus 1, x minus 1. 1 times 1 is 1. So we're ready to go. We're ready to practice completing the square here. So -2 parentheses x squared minus 2x plus 1. That's not really a plus 1 though. It's really 1 times -2, which is -2. So how do I counteract a -2? I add 2. Remember, you have to do the opposite of whatever this number actually is. So g of x equals -2, what squared? X minus 1 squared plus 9. Which gives me a vertex of right 1, up 9. I have to go right 1, up 9. And my leading coefficient is negative, so this is a maximum. So, hopefully you remember how to complete the square. If not, guess where you've got to go back to? You've got to go back to Unit 8, Lessons 8 and 9, I believe. It's week number 1 in Google Classroom. Week number 1 is how I review completing the square. It's a skill that comes up a whole bunch in your mathematical journey. So practice. We can go from standard form into vertex form by completing the square. See you guys.